Okay, a 1 kilogram ball moves to the right at 4 meters per second and collides head-on with a stationary 2 kilogram ball. Calculate the final velocity of each ball after the elastic collision. Okay, good. First of all, what information maybe we should draw out first. Draw the no. One thing is we should know what type of collision is this. First is say collides head on. What is the head on means to you? Head on means a head on collision means a one-dimensional collision. Okay, one-dimensional collision. Okay, one-dimensional collision, that means only have one component. Okay, only have one component. Right now he says moves to the right. That means this is for the x component, so it only has x component for this case. Okay, only has x component. Also, it doesn't have any angles, isn't it? No angles is mentioned. No angles is mentioned, so no angle. That if no angles means no x or y component. Okay. The word head-on itself already means one-dimensional collision. Only has one component. Okay. For this is a x component only, no y component. Okay. Only x component. So another thing is this one is an elastic collision. What do you understand about elastic collision versus inelastic collision? The key difference between elastic and inelastic, I hope you already clear. Elastic collision is the total kinetic energy. Okay, maybe I just want to write it over here. Elastic versus inelastic. Both of them, we can say both of them they are momentum. Okay, you can say momentum and total energy. They are conserved. Okay, both of them they are conserved. However, both one similarity between elastic and inelastic, both of them momentum and energy, the total energy, they are conserved. But however, the kinetic energy, yeah. So the kinetic energy. So this one, the elastic, the kinetic energy is conserved, but for inelastic, the kinetic energy is not conserved. Is not conserved. So that's the only difference. That's the only difference between elastic and inelastic collision. For elastic collision, the kinetic energy is conserved. For inelastic collision, the kinetic energy is not conserved. So if you want to differentiate between elastic and inelastic, you only check the kinetic energy. Okay, check the kinetic energy. Okay, so this one I just want to put to the other side. Okay, I want to put to the other side. Okay, now set this as background. Now let's solve these questions. Okay, so we have a ball 1 here. Okay, maybe we can draw out the situation here. Okay, this is the ball 1, and we have another balls here. Stationary, right? So this is ball 1, this is ball 2. Okay, so this mass 1 is 1 kilogram, and then this mass 2 is 2 kilogram. Okay, right now ball 1 is moving to the right, so this is the initial velocity u1. Moving to the right is positive, is positive, isn't it? Positive, so you should write a positive what value? 4 meter per second is moving to the right, so positive sign, positive 4, right? Yeah, collide head on means one-dimensional collision. So if one-dimensional collision, it will not result in oblique collision. That means it will result in only x component only have x component velocity. That's it. Yeah, only have x component velocity, only one dimension. Okay, this 2 kilogram ball 2, it is stationary initially stationary, so I can say is u2 is 0. U2 is 0. Yeah, u2 is 0. Now, what is the final velocity of each ball after the elastic collision? So this is before. So this is before collision. Now, what happened after? What happened after? We don't know. Yeah, we don't know exactly. So we can say we don't know how they move. Yeah, we don't know how they move. Right. So this is ball 1. This is ball 2. Probably this ball 1 will move backwards. Yeah, probably. I just assumption. I'm not sure. U2, ball 2 surely go to the right. Yeah, ball 2 surely go to the right. So we need to find this V1 and V2. Okay, so that's our job. We need to find V1 and V2 after the elastic collision. Okay, so one thing we can say about elastic collision is we can use two kind of formula. We can use two formulas. So look at what formula can we use. For elastic collision, we can use conservation of momentum. You see that? We also can use conservation of kinetic energy. Whereas inelastic, if inelastic only can use momentum, you cannot use kinetic energy because kinetic energy not conserved. So for elastic collision, you can use two. You can use for elastic collision, you can use formula for momentum, or total momentum. You also can use formula for total kinetic energy. But for inelastic, you only can use total momentum. You cannot use total kinetic energy because kinetic energy not conserved for inelastic. For elastic, you can use two formula. So that's why this one we can, even though you have two unknowns, you need to find final velocity of each ball, ball 1 and ball 2. You have two unknowns. Don't worry, because we have two formulas to be used. We have the total momentum formula. We have the total kinetic energy formula. We can build two formulas to find the two unknowns. Understand? That's why he tell you this one is an elastic collision, so that he wants you to use two formulas. One's for total momentum, another for total kinetic energy. Okay, let's roll. Okay, so first of all, we use the total initial momentum will be equal to total final momentum for elastic collision. We just use m1 u1 plus m2 u2. Again, this is a one-dimension collision, so you don't need to do x or y component. No x or y component because it's a head-on collision. Head-on collision is a one-dimension collision. Okay, m1 v1 plus m2 v2. Okay, so now let's do it. So okay, remember this is this part, this is before, and this part is after. Okay, so substitute accordingly. Okay, this one is 1 kilogram, so just put as 1 kilogram, and then u1 is positive 4, positive 4, yeah, because going to the right, plus M2 U2 is 0 because U2 is 0, stationary. You see, stationary, so U2 is 0. So when U2 0, momentum also 0. Momentum also 0. Now look at final after collision. Just now this part is before collision. Now the right hand side part is after collision. So what is mass 1? Mass 1 just now is 1 kilogram. So put as 1 kilogram. Okay, do we have V1? Oh, we need to find V1. We don't have. We just put as V1. Okay. And then M2 is 2 kilogram. We don't have V2 either. So we already have one formula here. So this is 4 equal to V1 plus 2V2. So here is our first formula. Okay, from the equation of conservation of momentum. This is from our equation of conservation of momentum. Yeah. Now, so this one we can put it below here better. Yeah. Sorry, hold on a second. How do I select? Yeah. How do I select? One. Yeah, this one. See that? How efficient? Okay. So I put it over here. Yeah. That's our conservation momentum. Now I just want to things more organized. That's my job. Yeah. I like to have things more organized. So that you as a student also need to be organized. You know that? You need to be organized in your work so that people will more respect you. Okay. Now, okay. Okay, so for elastic collision, you also can use the conservation of kinetic energy. Okay, that's the special thing for elastic collision. You can use conservation of momentum. You can use conservation of kinetic energy. However, for inelastic collision, you only can use conservation of momentum, but you cannot use the conservation of kinetic energy. Yeah, you can only use one formula. For elastic collision, you can use two formula. For inelastic collision, you only can use one formula. Okay, right now is elastic collision, you can use two formula. Okay, so right now let's look at this one. So this one you can use conservation of kinetic energy. Okay, for elastic collision, the kinetic energy is conserved. That means the initial total kinetic energy is equal to total final kinetic energy after collision. The kinetic energy before collision equal to kinetic energy after collision. So, okay, hold on a second. Okay, so what's the formula for kinetic energy? Yes, it is half m1 u1 square plus half m2 u2 square equal to half m1 v1 square and then half m2 v2 square. So okay, one thing is, you see we have half here. All of it have half. We don't like this half. We can just cancel it. Divide by half. So these common terms, you see, and whenever you see common terms, you can just delete it. When you see common terms, you can just divide the common terms and the common terms will disappear. You see that? Now, what is mass 1? What is mass 1 again? Mass 1 is 1 kilogram. Okay, so substitute all the values. We have the mass 1 as 1 kilogram, and then U1 is positive 4. Okay, and then we have mass 2 as 2 kilogram. Oh, this one is 0. You see that? Because U2 is 0. So this one is 0. Understand? 0. And then continue. So mass 1 is 1 kilogram, and then V1 we don't know. Yeah, that's what we want to find out. And then we have mass 2 is 2 kilogram, and this is V2 square. Okay, that's it. Yeah. So okay, so we got the second formula already. So this is 16. Yeah, 4 square is 16. And then we have a V1 square, V1 square. Yeah, and then we also have 2V2 square. So here we have the second formula. Here we have the second formula. So we have two unknowns here. Here we have V1, V2. Here also we have V1 and V2. So we do simultaneous. We do simultaneous equation. We can find the V1 and V2 already. Okay. So how do we do this? Seems like we need to do substitution. So for equation 1, you substitute, what do you do? Yeah, just put V1 equal to just put V1 equal to 4 minus 2V2. Okay, V1 is 4 minus 2V2. Okay, so then substitute. So you can actually put this okay, put this as equation 1. Okay, this one equation 1. You substitute into here. You substitute into the V1 here. So look at equation 2. Now look at equation 2. Let's solve it. Yeah, let's solve it. 16 equal to V1. V1 is 4 minus 2V2, yeah, according to equation 1. And then don't forget the square, yeah, because the V1 got square. So then 2V2 square, and then we need to we need to expand. This becomes 16, and negative 2 times 4, 8. 8 times 2 is 16. 16 V2. Okay, negative 16 V2, and then negative V2 square. So we get a positive 4 V2 square. Okay, that's how we expand. And then plus 2 V2 square. So what do we get? We can cancel off this 16 here, cancel off. We minus out. And then what else? We have 0 equal to a negative 16 V2. And then here we have we have 6 V2 square. 6 V2 square. So now so we got what? We got 6 V2 square minus 16 V2, isn't it? 16 V2. So we can factorize out the V2, and then this one is 6 V2 minus 16. So we got the V2 is equal to 0, and also V2 is equal to what's the answer? What's the answer? Okay, let's find out. It's 8 over 3. It's 8 over 3, which is 8 over 3 is 2.67 meter per second. Okay, 2.67 meter per second. Now let's find out the V1. Okay, we have two answers here. V2 is 0. Is it feasible for V2 0? Look at V2 equal to 0, and V2 we have two answers. Do you think it's feasible? V2 to be 0? Yeah, is it feasible for the final velocity for ball 2 to be 0? When the initial velocity is 0, the final velocity for V2 also after collision becomes 0? Do you think it's feasible? Do you think the V2, is it possible to be 0? Do That means you see, initially ball 2 is not moving. It's not moving. And then ball 1 bang onto the ball 2. Then ball 2 choose not to move also. Ball 2 choose not to move, remains stationary. It remains stationary. And the ball 1 is reflected backward. Deflected backward. So do you think it's possible? This ball 2 is not fixed to the surface, it's not gummed onto the surface. No. This ball 2 surely is free to move. Yeah? Surely after collision, after ball 1 collide the ball 2 surely push to the right. It surely move to the right, isn't it? Ball 2 can never remain 0. Ball 2 can never remain stationary. It cannot remain stationary. So it's not feasible, it's not possible that ball 2 remains stationary. So when you say final velocity ball 2 is 0, yeah, which you get from the calculation here, you say ball 2 remains stationary after collision is not possible. So we say that this is not possible. We say neglected. We neglect this answer. We neglect the 0. Yeah, because it's not possible. It's not possible for ball 2 to remain stationary after collision. Okay. So it's not 0. Yeah, it's not 0. It should be what? Yeah, it should be I got the positive answer here. You see, I got positive velocity here. Positive means what? Positive means it moved to the right. It moved to the right. You must write the direction also. Move to the right. Because talking about velocity. Velocity is a vector. You want velocity means it's a vector. Vector, you need to give two things. You need to give magnitude and also direction. So you need to explain the direction in words. You understand that? So you need to say direction to the right for velocity 2 because got positive value. So we know that the V2 is already 2.67. 2.67 positive. Positive means to the right. Okay, positive 2.67 to the right. Now we need to find V1. We substitute this one. V2 back to here. We substitute back to here. Then we can get V1. Okay, get V1. V1 is equal to 4 minus 2. What's our V2? V2 is positive 2.67. So what's the answer? Let's calculate. Okay. All right. So hold on a second. 2 times 2.67. We got this 4 minus answer. Yeah, the answer is V1 is negative 1.34 meter per second. What is mean by the negative sign here? Means it moved to the left. Ball 1 moved to the left after collision. I must write the direction. So correct, my prediction is correct. The ball 1 after collision with ball 2 moved to the right. Yeah, so positive velocity. Ball 1 is negative, move to the left. It rebound. Okay, it rebound. So the V1 is positive, is negative because move to the left. Negative. What's the answer? Negative 1.34 meter per second. Move to the left. Okay. So that's the answer. Is it correct? Answer is 2.67. Yes, 2.67 is correct. Positive. Positive means move to the right. Yes. And then negative 1.34. Negative 1.34. negative 1.34, negative 1.34. Yes, move to the left. Negative means move to the left. Yes, correct. My answer is correct. So this question very simple. Whenever you see elastic collision, means you can use two formula to find the two unknowns. Yeah, you can use a conservation of momentum, and then you also can use conservation of kinetic energy. Okay, conservation of kinetic energy for elastic collision. Okay, so m1u1 plus m2u2. This one is half m1u1 square plus half m2u2 square. Okay, that's it for this question. Okay, see you in the next video.